RokiSim is the short form for Robot Kinematic Simulation software. Many of us may not have the physical access to these industrial robots, therefore making it difficult for us to learn these robots in close detail. Such simulation software has the virtual models of many of the famous industrial robots by companies like ABB, KUKA Robotics, Motorman Robotics, etc. These models help us to learn them and also simulate them so that one day when we see the real robot, we will not be surprised by its behavior. Welcome to the demonstration of the RokiSim software. RokiSim is a free software. Ro stands for robot, Ki stands for kinematic, and Sim stands for simulation software. Google it and download the software and install it in your system. Once you open the software, go to the file and load a robot of your choice. Then move to the view menu. You will find that there is a robot control panel, there is an object panel, and there is also a simulation panel at the bottom. Usually we have the simulation panel and the control panel open. So you can see the robotic arm here. This robotic arm can be controlled using your control panel. Now let's have a look at the control panel. The first option which we see in the control panel says reference frames. The first one is the world frame and the second one is the tool frame. Frame is nothing but an origin with the X, Y and Z axis. The world frame is usually positioned at the base of the robot and the tool frame is usually positioned at the end of the robotic arm where the tool is attached. A robot is made up of many links. This could be a link, and this could be another link, and this could be another link. The two links are connected by a joint. Here you can see in the control panel there are many frames, that is, each link has its own frame. The next section talks about the joint jog. So here you can see this robot has 6 joints, each represented by theta 1, theta 2, theta 3, theta 4, theta 5 and theta 6. This tells us about the position of the particular joint. You can drag the slider to move the particular joint. These sliders can be used to move your robot joint wise. If you want to go to the initial position, click on this button which says Init. The next section says Cartesian jog. Here the first label says as position. So this talks about the position of your tool tip, which is here. And the next label says orientation. This talks about the orientation of your tool. You may move your tool in two ways. You could either translate it or you could rotate it. Let me translate towards the x-axis. Now I am translating about the y-axis. Now I am translating about the z-axis. So translation is usually a straight line motion. You can also rotate your tool about a particular axis. X-axis, now y-axis, and now the z-axis. Now let us look at the two basic concepts behind any robotic arm: the forward kinematics and the inverse kinematics. By kinematics, we talk about the motion of the robotic arm without considering the forces that are acting on the arm. Set each of the angle at a particular position and then calculate what is the tool tip position and the orientation. Now this is called as the forward kinematics. Setting your tool end point and then calculating the joint angles is called as your inverse kinematics. The thing about the inverse kinematics is you can have multiple sets of these angles which can have the same tool tip end point. For example, this drop down shows the various position of the angles where the tool tip and orientation remains the same. So these are all the various solutions of your inverse kinematics problem. So for a forward kinematics problem, you have only one solution. For inverse kinematics problem, you have lots of solutions. So now this is a quick look into the world of robotic arm. See you next time.